We begin a question answer session on network, and this is lecture number 2. First question. Show transformation relation between voltage source and current source. Let us come to the answer. Consider a voltage source Vs in series with a resistance R. Let us represent in a diagram. This is voltage source Vs represented by the circle symbol with positive and negative sign within it. The top side is taken to be positive. This resistance, obviously in series with Vs, is called R. The output terminals are connected to an external circuit. So this circuit represents a voltage source. An equivalent representation of the voltage source Vs in series with a resistance R can be made through a current source representation where the source current is Is equal to Vs by R and it is in parallel with the resistance R. Let us show the current source representation that is equivalent to the voltage source. This is Is, the current source, denoted by a circle with an arrow. The direction of the arrow indicates the flow of current from it. Since the voltage source Vs has positive at the top, the arrow of the current source Is will be upwardly directed. This resistance R is in parallel to Is, and the two output terminals are connected to the external circuit. So voltage source Vs in series with resistor R is equivalent to a current source Is equal to Vs by R in parallel to the resistor R. This is the transformation relation between the voltage source and the current source. Let us start other way around. Consider a current source Is in parallel with a resistor R. Let us show it. This is current source Is in parallel to the resistor R connected to an external circuit. Equivalent representation is by a voltage source Vs equal to Is into R in series with resistance R, and this is it. The terminals connected to the external network. This is the transformation relation between current source and voltage source. Next question. Find I in the circuit and let us show it. There is a 10 milliampere current source in parallel to 5 kilo ohm resistance. This is a 4.7 kilo ohm. Current through it is I say. It flows through another resistor 3 kilo ohm, and this is a voltage source of 3 volt. The options for current I are the answer. Let us analyze the circuit to find I. Given circuit is, let us redraw it. Let us name these nodes A and B. Now we focus attention to this portion, which is a current source 10 milliampere in parallel to 5 kilo ohm. Convert it to voltage source Vs equal to Is into R, which is 10 milliampere into 5 kilo ohm equal to 50 volt, and it is in series with 5 kilo ohm. Let us draw the circuit with this transformation from current source to voltage source. This is the voltage source of 50 volt in series with 5 kilo ohm resistor, and we draw the rest portion of the circuit that has been untouched. Now combine series resistances 5 kilo ohm plus 4.7 kilo ohm plus 3 kilo ohm to get 12.7 kilo ohm. We redraw the circuit with the series combination of resistances, and current flowing across 12.7 kilo ohm resistor is I. Apply KVL, Kirchhoff's voltage law, to get 50 volt minus 3 volt equal to 12.7 kilo ohm into current I. This gives I equal to 3.7 milliampere. So this option is correct. Next question. Find R in the circuit and let us draw it. This is a 5 ampere current source and I is the current in the circuit. This is a current source. Look at the arrow. It is a voltage dependent current source as evident from the quantity 2V that is used to describe the current source. This is resistance R and V is the drop across it. The options are. We come to the answer now. Let us redraw the given circuit. Current in the circuit is equal to 5 ampere as evident from the current source that sends 5 ampere of current. Again, the voltage dependent current source sends a current of value 2V. And this is resistance R, the drop across which is V. Since in this one loop circuit, current across any point has to be same because of charge conservation, it is expected that current in the circuit is equal to 5 ampere is equal to 2V ampere. This is the voltage dependent current source we are referring to. In fact, the voltage dependent current source sends current of amount 2V ampere. So V equal to 5 by 2, the unit of V being volt. So we write 5 by 2 volt. Voltage across R is V, which is by Ohm's law current into resistance. Now V is 5 by 2 volt, current is 5 ampere and resistance is R ohm. This means volt on both sides. Hence R is half, that is 0.5 ohm. So this option is acceptable. Next question. Find I in the given circuit. Let us show the circuit. A 5 ampere current source in parallel with resistance 3 ohm. This is 7 ohm. This is 4 ohm. This is a current source and this resistance is in parallel to it. The current source is 3V1, so it is a voltage dependent current source. We shall indicate which voltage is V1. This resistance is 17 ohm. This is 9 ohm and this is 2 ohm. The voltage across this resistance is V1 that decides or controls the current of the current source 3V1. And I is the current in this portion of the circuit across 2 ohm resistor. The options are. We come to the answer now. Consider the given circuit. We redraw the circuit. Focus attention to this portion and we will replace 5 ampere current source that is parallel to 3 ohm resistance by a voltage source Vs equal to Is into R. Now Is here is 5 ampere and R is this 3 ohm. So we get Vs to be 15 volt and for equivalence it has to be in series with the 3 ohm resistance. Let us show this portion we talked about. 15 volt voltage source is here. As the arrow of the 5 ampere current source is upwardly directed, the positive of the voltage source is up here. It is in series with 3 ohm resistance. 7 ohm here and this is 4 ohm. We next turn attention to this portion of the given network. We would replace the current source 3V1 parallel to 17 ohm resistance by a voltage source Vs equal to Is into R. Now Is here is 3V1 ampere and R is 17 ohm. So we get Vs to be 51 V1 volt, which is a voltage dependent voltage source. Earlier we had a voltage dependent current source, and for equivalence it has to be in series with the 17 ohm resistance. Let us show this portion we mentioned. 51 V1 voltage source is here, as the arrow of the 3V1 current source is directed towards right. The positive of the voltage source is at the right here. It is in series with 17 ohm resistance. Let us draw the 2 ohm resistance part that carries current I and the drop across which is V1. Now we look forward to this portion. We would replace the current source 1 ampere parallel to 9 ohm resistance by a voltage source Vs equal to Is into R. Now Is here is 1 ampere and R is 9 ohm. So we get Vs to be 9 volt, and for equivalence it has to be in series with the 9 ohm resistance. Let us show this portion and complete the equivalent circuit. This is the 9 ohm resistance that is in series with the 9 volt voltage source, which is here. As the arrow of the 1 ampere current source is directed up, the positive of the voltage source is also up here. Circuit is completed. In the next step, we redraw the circuit, combining series resistances 3 ohm and 4 ohm that adds up to 7 ohm. And then 17 ohm and 9 ohm can be combined to 26 ohm. With this, the look of the circuit will be We now again look at this portion, and we would replace 15 volt voltage source in series with 7 ohm by a current source Is given by Vs divided by R. Here Vs is 15 volt and R is 7 ohm. This leads to the value 15 by 7 ampere, and for equivalence it has to be in parallel to 7 ohm resistance. Let us show the resultant circuit that gets greatly simplified now. This is 15 by 7 ampere current source in parallel to 7 ohm resistance. Let us draw the rest portion of the circuit. Look at this portion. Two 7 ohm resistors are in parallel. We would redraw combining them, and this gives 3.5 ohm. Here is the simplified network. This looks like the penultimate step to convert the given complicated network into a single loop, a single circuit, no branches. Focus here, and we will replace 15 by 7 ampere current source in parallel to 3.5 ohm resistor by a voltage source Vs equal to Is into R. Here Is is 15 by 7 ampere and R is 3.5 ohm. This gives 7.5 volts, and for equivalence it has to be in series with 3.5 ohm resistor. The simplified circuit we end up with is here. Just a single loop, and we shall apply KVL, Kirchhoff's voltage law. We have to be careful, we have to follow the appropriate sign convention, and by doing it we get 7.5 volt plus 51 V1 volt minus 9 volt equal to I into 3.5 ohm plus I into 26 ohm plus I into 2 ohm. This gives. Now what is V1? Look at the 2 ohm resistor in the circuit, the drop across which is V1 volt, and the voltage is, by Ohm's law, current into resistance. Look at this part. What is the current? It is I. And what is the resistance? Obviously 2 ohm. It gives thus 2I. This leads to I equal to 0.022 ampere. So this is the correct option.